Hello everyone. So now we'll discuss about cell representation. In the last session we have discussed about what is EMF, what is cell potential. Now we'll discuss about cell representation. How to represent a cell. So here, if I consider a galvanic cell, so this is an example of a galvanic cell. Galvanic cell. So for sake of simplicity, I will consider a galvanic cell. The best example of galvanic cell is our Daniel cell. I will consider Daniel cell here. So let us discuss about cell representation by taking an example of Daniel cell. Now you know the construction of Daniel cell. We have to take two separate beakers. In one beaker, zinc sulfate solution is poured, the electrolyte zinc sulfate, and it is in this beaker will dip zinc electrode or zinc rod, and this zinc rod is externally connected with copper rod, which is dipped in another beaker which contains the electrolyte copper sulfate as the electrolyte, and these two beakers are internally connected by using a salt bridge. Okay, now so this zinc dipped in zinc sulfate ion, this is called as half cell, zinc half cell or oxidation half cell, as we have discussed in our previous sessions. Now what is this? So we can call it as reduction half cell. In this half cell reduction reaction takes place, so it is called as reduction half cell. Here oxidation takes place, so it is called as oxidation half cell. And so now we'll discuss cell representation. And please remember, according to IUPAC recommendations, we will take oxidized electrode, or the electrode which is undergoing oxidation, means anode is always taken at the left. So if I consider this is my right side and this is my left side, so always anode is taken on left. Please remember this, anode is taken on left, and at the right we will take cathode. So writing a cell, we must remember that we must follow that anode should be written on the left side and cathode should be written on the right side. So now based on this, we have to represent a cell. To represent a cell, symbolic representation of cell. To represent a cell, we have some notations. So this is a rough or brief idea to represent a cell. How to represent a cell? So here I will compare this flowchart with my experiment. So here this is zinc electrode. Zinc electrode is dipped in zinc sulfate ions or zinc ionic electrolyte. So here the concentration of electrolyte is 1 molar, and this zinc is present at the anode and this is negative in charge. So here this is my zinc dipped in Zn2 plus ionic solution, and this is my anode, and anode is negatively charged. At this electrode oxidation takes place, at anode oxidation takes place, and at the another side, and the right hand side, I have got copper. Here my electrode is copper electrode which is positively charged. Here it is positively charged, and this copper is dipped in the solution or electrolyte containing Cu2 plus ions. The cupric ions are present. So here the solution containing cupric ions, the concentration of solution is 1 molar concentration. Here also it is 1 molar concentration, and at this electrode reduction takes place. At that electrode reduction reaction takes place, and these two half cells are divided by salt bridge. Actually they are internally connected, but they are physically divided by salt bridge. So salt bridge are present at the middle. So based on this, we have to represent a cell. For the representation of cell, we have to write, first we have to consider anode, then we have to consider cathode. First we have to write the anode, the metal present at the anode. So for this Daniel cell, here the metal present at anode is zinc. Here it is zinc. Zinc is our metal, and zinc is dipped in which electrolyte? The electrolyte containing Zn2 plus ions. It is dipped in Zn2 plus ions. It is in the aqueous form, and we have to mention the concentration of this electrolyte. What is the concentration of electrolyte? 1 molar. The concentration of electrolyte is 1 molar. So this is my anodic half cell. Anodic half cell. And this anodic half cell is separated from cathodic half cell by using salt bridge. To represent salt bridge, I use two lines. So one line separates metal from its electrolyte, and these two lines differentiate or separates these two cells, the half cells. Okay, so this is known as salt bridge. This representation is known as salt bridge. Now what we have to take, zinc dipped in Zn2 plus ions whose concentration is 1 molar, and these are separated by salt bridge. Now we have to take copper. The right side electrode is cathode. The electrolyte present in the cathode is copper, Cu2 plus. Then we have to mention its concentration, 1 molar concentration, and it is dipped. In this electrolyte, the copper metal is dipped, Cu. So this is the cell representation for Daniell cell. For this cell, this is the cell representation for Daniell cell. Daniell cell, the cell representation of Daniell cell. To remember this, I'll give one simple trick here. I have to consider this cell, galvanic cell. So from the left, we have to take from the left to right. We should move from left to right. See here first we have taken zinc electrode. First we have dipped zinc electrode. This zinc electrode is dipped in which solution? Zinc solution. The solution containing zinc ions, and the concentration of that solution. And this solution is internally connected with the salt bridge. So this salt bridge is connecting this solution with this solution. So after this solution, we'll write this solution. These two are internally connected. Here for this electrode, first we have to write the electrolyte Cu2 plus, and in this electrolyte the copper metal is present, copper. So for anode, first we write metal, then electrolyte, and for cathode, first we write electrolyte, then metal. Okay. So this is the cell representation for Daniell cell, and for this we know that how to calculate E cell or EMF of the cell. What is the formula to calculate EMF of the cell? E cell is equals to E right minus E left. So this is the formula to calculate the cell potential or EMF of the cell. E cell is equals to E right minus E left. E right means what? The electrode potential of right side electrode minus electrode potential of left side electrodes. So for Daniell cell, E cell is equals to how much? E cell is equals to, for Daniell cell, on right hand side, which electrode is present? Cathode is present, and the cathode, the copper. Cathode is nothing but copper. So we have to take E Cu2 plus bar Cu minus E Zn2 plus bar Zn. So this is the E cell or EMF of the Daniell cell. It is given as electrode potential of copper electrode minus electrode potential of zinc electrode. So here I have taken Cu2 plus bar Cu and Zn2 plus bar Zn. This indicates the reduction reaction. Metal ion is converted into metal. If I write like this, Cu bar Cu2 plus, what it indicates? This is reduction. Which potential we have to consider? We have to consider only reduction potential as electrode potential. So because of that reason, I have taken the reduction potential of copper minus reduction potential of zinc. So this is nothing but cell potential. Okay. So now let us discuss, or before going forward, we'll discuss one more example of this type. So now I'll take the solution as, here on this side I'll take copper. Here this solution is copper sulfate solution, and on right hand side I will take silver electrode. Now here electrolyte is Ag2SO4 or I can take AgCl. So here we have to take electrolyte. It must furnish Ag plus ions. Now for this electrode or for this galvanic cell, here the galvanic cell is made by copper with silver. Copper with silver. In the presence of silver, copper behave as anode and the silver behave as cathode. So I will just remove this. And however, we know that how to represent a cell, and directly I will represent cell. First I will write the chemical reaction taking place in this cell. The cell reaction, the overall reaction taking place in the cell. So here I have taken copper at the anode. Copper at the anode. Anode means what? Which it must undergo which reaction? Yes, oxidation reaction. Copper must undergo oxidation and silver must undergo reduction. Now the overall chemical reaction for this cell is Cu plus 2Ag plus, which is in the aqueous form, gives Cu2 plus plus 2Ag. So this is the overall reaction taking place in the cell. The overall reaction means what? This is not a single reaction, but it is a combination of two type of reaction. So what are those? At anode. At anode, which reaction is taking place? Oxidation. In this, which is oxidized? Here, the copper initially it was present in its zero oxidation state. Now it is converted into plus 2 oxidation state. Here, oxidation state of copper here it is 0. Now it is plus 2. Means copper is oxidized. So we have to write the Cu S gives Cu2 plus 2 electrons. So this is oxidation half reaction which is taking place at the anode. So this is oxidation half reaction. At cathode, which reaction is taking place? At cathode, reduction reaction takes place. Reduction means what? The silver is present as plus 1 here. Now the oxidation state of silver here it is in zero oxidation state. Means the plus 1 is reduced to 0. Means this component is reduced. Ag plus 2Ag plus. Here 2 Ag plus ions means 2 Ag plus ions capture 2 electrons, means each ion, each silver ion will take 1 electron and it is reduced to give 2 Ag, the silver atoms. So this is at cathode reduction half reaction taking place. This is my oxidation half and this is my reduction half reaction. And now we'll represent cell. So how to represent this cell? As already I have explained, first which electrode I have to consider? Yes, we have to consider first anode. At anode I have got which? Cell representation. Cell representation. At anode I have copper electrode, and this copper electrode is dipped in copper sulfate solution. The concentration of this electrolyte is 1 molar concentration. If concentration is not mentioned, just we have to write aqueous. In the examination, if they are not given concentration, we have to write only aqueous form. Copper and dipped in copper electrolyte, and this is separated by salt bridge. Now here which electrolyte is? Silver electrolyte. We have to take only ionic form, Ag plus in the aqueous form. The concentration of these ions is 1 molar concentration, and this solution is dipped with Ag, silver. So this is the cell representation of this cell, the given cell, the cell representation of given cell. Okay, here at anode first we have to write anodic part, then we have to write cathodic part, and these two parts are separated by salt bridge, and this indicates the interface between electrode and electrolyte. This single line indicates the interface between electrode and electrolyte, and this indicates the separation between these two electrodes, the anode and the cathode. Then what is the electromotive force of this cell? E cell or EMF of the cell is equals to. So what is the formula to calculate EMF of the cell? E cell is equals to E right minus E left. On the right side, which electrode we have got? Cathode. Cathode is made up of silver. So now E right means what? AZ plus bar AZ minus E Cu2 plus bar Cu. So this is the formula to calculate EMF of this cell. The given cell EMF, the EMF of this given cell can be calculated by using this formula. E cell is equals to E right minus E left. On the right hand side we have got silver electrode. On the left hand side we have got copper electrode. E silver minus E copper. The electrode potential of silver minus electrode potential of copper. So this is about the cell representation. How to represent a cell. Okay. Thank you.